Greetings and welcome to another Moralis Axelar live stream event. I'm joined by Idris again today, and if you've seen any of our previous streams, you know you're in for something good. This time, we're going to have a chance to do a little bit of background discussion about our industry, finally leading up to an explanation and then demonstration of the GMP, General Messaging Protocol for Axelar. And I'm going to go ahead and bring Idris up on stage here. Idris, how you doing today? Welcome to the show. Glad to have you. I'm very excited to look into this, and I got to look at your notes beforehand. So I'm also excited to talk about how we got to where we are a little bit, which I think is going to be a focus of this one today. Before we get going, folks, hit the like and subscribe if you want to see more content like this. I'm Phil, head of research at Moralis, and we're looking forward to seeing you not only at this stream, but other ones as well. Let's get started here, and I'll go ahead and bring your shared screen up here so we can get going.
Yes, thank you, Phil. Hi, everyone. Welcome once again. I'm really excited to have you all here. And then today, we'll, of course, like we give the best. Yeah, so we are going to go through sending, cross-stream messages with Axelar GMP, which is the Axelar General Message Parsing for short. So today, I'll be talking about what exactly do you need, like how everything started. What do you need to send cross-stream messages? And also, what are some of the existing problems that we have in the space even before this cross-chain functionality is being introduced? Like, what are some of these things that we face in the current ecosystem that cross-chain capability, interoperability ecosystem was being discussed, and everyone is really excited about it. So let me just get right into it. So yeah, my name is Idris Olubisi. Once again, I am a developer advocate at Interrupts Lab working on Axelar, and you can find me on all socials at _Olanesoft or Olanesoft. All right. So in the beginning, we had many blockchains. We have a lot of ecosystem, but at the very beginning, between 2009 to 2017, we had blockchains like the Bitcoin, of course, the first, and then we had Ethereum. Before Ethereum, the Bitcoin was introduced or like built, announced publicly to solve the problem of peer-to-peer, payment system. And then which happens like to go live and everything is working fine. But at some point we wanted to like even go further by leveraging the blockchain technology to allow builders to build application, decentralized application. And then we had Ethereum. So Ethereum allow this peer-to-peer, like building on the current system that we had, and then allowing developers to build, to have custom application, build and deploy smart contracts on chain, and then allow all of these things happen. So during this period, we've seen like precedent boom in, everyone is talking about the blockchain. Everyone is really excited about, the mainnet launch. Things are really going well. And then, but going forward between 2017 to 2023, we had like even more and more chains spin up, right? We began to see some of these existing problems with layer one solutions, which we had between 2009 to 2017. And then the problem centered around, scalability, transaction throughput, and also processing, faster transaction and all of these things. So we began to see layer two solutions. We began to see the likes of Avalanche, Solana, we can see the like of Avalanche, Polygon, and all of these, guys, optimism, talking about how they could scale the ecosystem to even have even more, transaction throughput and also making everything happen on chain. But it didn't stop there because we have several use cases at the point, right? Some users are interested about privacy. Some are interested about some users are interested about privacy. Some are interested about, I just want my application to work. I don't care. I don't care what's happening under the hood. So during this process, we began to see even more and more, blockchain spin up to solve this particular problem, right? As you can see on the screen, where we have from like 2017 to 2023, and then from 2024 to the future. Yeah, you want to say something, Phil?
Yeah, well, I wanted to mention, it's great to see this breakdown here because if you were around during the beginning days, anywhere in that time frame, you remember what interoperability looked like. It was basically non-existent, right? You had central exchanges that would accept a variety of different tokens from different blockchains. Just about every single blockchain was not smart contract capable. There were a few experimental exceptions. And then finally, Ethereum changed the game, but that also changed the paradigm where it was Ethereum was able to do all these things that none of the other chains could do. And there was this question of how are we going to reconcile that? And that was where, the first semblance of interoperability like we know today emerged, where, and maybe even before that, we could reference, atomic swaps, where we weren't really sending messages. We were just creating a compatible transaction that allowed the virtual interoperability between chains. But, all of this leading up to what we're of course talking about today, which is a real awakening. So I love to see,
Yeah.
2024, we're starting now, guys, because what we're about to see today really does reinvent a lot of these ideas and improve upon what we've been testing for what is getting close to 2 decades at this point.
Yeah, exactly. Thank you very much for that. So one thing I also want to point out is there are a few questions around during this time, right? There were a few questions around how do we scale when we get to add more and more protocols with these capabilities and features? So how do we make this process seamless, even for new developers or enthusiasts? Because like I mentioned earlier, like users have private needs, like different needs rather. Some really care about costs. They just want things to be really cheap. And then some people care about security. They don't care. They don't care about the cost. They don't care about privacy. All they want is they want their application to be secure. And then other users like care about privacy. Like they don't also care about cost and probably security, even though they always want good security, but then at some point they really care much about privacy. So every decentralized application with different use cases and more decentralized application means we need to have like more chains. So the more we have chains, the more we see decentralized application being built on all these chains. So I think doing like with this explanation, I already mentioned the problem, but then it's very important to state that there was a problem at this time. We began to see so many chains like spin up, solving one problem or the other. And at some point, we also see like the problem of what is going to happen within the ecosystem, because now we have like tons of chain. Tomorrow you see an announcement, and a day after you see another announcement, and all of these things, right? But then how do we connect this ecosystem together? And then what exactly was the problem? So I didn't mention the problem yet, but then the problem was the siloed ecosystem, right? So we did not have like this interoperable ecosystem between EVM chains or like EVM to Cosmos. What exactly do we need that could sit in between, these two ecosystems and then connect this ecosystem in a decentralized manner? That's something we didn't have in the beginning, right? So this is
Absolutely.
a major problem. Yeah, this is a major problem within the space. And, solving this problem just means that you are enabling cross-chain interaction between all of these chains seamlessly. And then it's also important to note that doing it in a decentralized manner is a step ahead of any other approach. So
one other thing I wanted to mention there
yeah,
before we keep going, these siloed chains that we're not able to connect with one another is something that we've been talking about for years. And even prior to this year, even at the launch of things like Polkadot and Cosmos, there was this idea in the mind of developers that this was going to solve interoperability. But the problem was simultaneously, another chain is coming out that doesn't follow those standards. And so really the new question became, okay, how do we unify these other new solutions with some solutions that have a form of interoperability, but it's certainly not global interoperability. And I think you guys can get what I'm hinting at here as we go forward.
Yeah, exactly. That's correct. But then with all of these problems, how do we fix them, right? So this is where we also not just fixing them, but there are a few concerns that we should talk about. So as a developer or as a builder or as a user, What if I did not care which chain, I was on? I just want to like connect my wallet and then send assets between chains. I don't want to, understand the technicalities involved. So what if I, take advantage of like chain differences, because now a decentralized application built connect all of these chains together, and then as a user, I don't have to like, go through the hassle of, I need this asset on this particular protocol. Oh, how can I do that? How can I do this? Like, I just want to, I'm on your DApp. I want to interact with your DApp, your decentralized application, and then I want to do anything on the DApp, right? And another thing is, what if as a product, you could be where your users are? Now you've launched your project on chain A, and then you've been seeing people talking about, chain B, and then you feel you are interested about like this discussion, and which actually a cool addition if you could expand to that particular ecosystem. So what if that's it's something that is very, very important with you, and you don't have the time to start reinventing the wheel or start building or thinking about the architecture, for you to, you already set up on the chain, and then you are planning to see how you can extend that capability to other chains. So all of these things are concerned because they are big problem. Despite the fact that we know that we need like an interoperable ecosystem, we also need to talk about some of these concerns, these underlying concerns. So what is the solution? This is Axelar. That's where Axelar comes in, right? Axelar protocol itself is a decentralized interoperability network that securely connects different blockchains and allowing assets, application, and users on various chains to seamlessly interact. So this what the chain is solving here is a major pain point in the blockchain, adoption, right? And then this fragmentation across the entire ecosystem. So because Axelar trusted inter-blockchain communication protocol enable cross-chain possibility without compromising security, which is very important to lay emphasis on, compromising security or control. So the network is blockchain agnostic, and then it connects all of the chains. As of today, we have 60 plus, supported blockchains because it's a proof of stake, network on its own with its own validity. We have over 75 active plot validity, and you can also see the number of transactions that has been processed so far. And the cool part is that Axelar is simple to use, integrated into over 60 plus chains. So when I mean simple to use, I'm talking about like from the DX point and also some other tools that we have for no codes for people that don't have like technical experience and they still want to do something with it. Axelar network, right? So, and all at the same time, which is like the most important thing to talk about is security and decentralization focused, right? Because it's proof of stake blockchain that connects other blockchain. You should know that security and decentralization is priority for us. So you can check it out. You can check out axelarscan.io, and then you should be good to go. So
And
now,
also wanted to add, from
yeah,
the ease of use perspective, if you're using a bridge solution such as Squid Router or something similar to that, you might already be using Axelar on the back end and not even realize it, especially if you don't click the link to view the block explorer and see that transaction taking place. Now, if you want to get
yeah,
hands-on with this, that's something we're taking a look at very soon in our over on one of our other YouTube channels. And so we're going to be posting a video there soon. That's over on our Moralis Money channel. So check that
yeah.
out if you haven't already to see some firsthand steps with using Axelar. Back over to you, Idris.
Yeah, thank you very much for that. So let me quickly talk about like some of the functionality that you have out of the box, leveraging the Axelar network. So we have access transfer. Under access transfer, we have deposit addresses, we have send token function, and then we have interchain token. Don't worry, I'll go through all of these things one after the other. So the first one is deposit address. So a deposit address is a temporary special address that is created and monitored by the Axelar Relayer service on behalf of the requester. So what does this mean? Let's say you want to build a decentralized application and then you want to programmatically generate a deposit address that could allow user to send assets from chain A to chain B. So what you need in this case is to just build your front end, your cool front end, and then just make calls or interact with the SDK that we have provided, and you can trigger this particular function to get deposit address, and of course with all of the required information. That way, the return deposit address would be a typical address to receive funds, and then whatever funds that is sent to that particular address this is specifically the assets that was specified here in this function. So after the asset is sent to that particular address, it will get routed automatically because this address, this temporary special address, is monitored by the Axelar relay service, right, on behalf of the requester. So a few things to note here is that you need to specify the environment because testnet is developer production. So yeah, testnet. Yeah. So and if you also want to like specify mainnet, then please go ahead and specify mainnet. And then call this function, specify the from chain, which is the source chain you're sending from. Maybe you're sending from base, and then to chain you're sending to optimism, right? So that's base to optimism. You need to also specify the destination address. So in this case, the address is meant to receive that particular asset, and then the particular assets you want to transfer, and that's all you need to make this call to get deposit address. So you can check this out, on your own. And you see how cool it is to generate deposit address on the fly and also send assets to it immediately. So moving on, we also have the send token function. So the first one I talked about is deposit address. This send token is a little bit different because the first one is when you're interacting from your front end, right? You have like a JavaScript, TypeScript application that you're building and you want to like make SDK interactions. But then send token is a function on the Axelar gateway EVM contract that facilitate token transfer between EVM and Cosmos chains, right? So why this one is different is, well, you need to call this function on your smart contract. So let's say you have a smart contract that you build and you want to be able to send token from one protocol to the other. What you just need to do is to import the Axelar SDKs and then call this particular function on your smart contract. Specify the destination chain name, specify the destination address, and then you specify the asset symbol and the amount that you want to send. And so calling this particular function automatically on your contract will trigger that functionality to send these assets from chain A to chain B.
Got a
Right.
quick
So,
question here in the chat regarding
okay.
relayer services and how the security is maintained in the process you're describing. Maybe you're going to get into that later on, but since I saw it in the chat there, I wanted to pull it up on the screen. Let me know if you want to take it now or later.
Yeah, I think I can talk about it now because Axelar Relay service, this particular service is coming. Let me take it back to the screen that we have. So this particular service is, yeah. So this is a temporary for deposit address. Like we have Axelar Relay service, which is different from the network. This is option services, and then this can be built by anyone, right? But particularly for this feature, which is deposit address, we have these services that is going to monitor whenever its temporary address is created, it's going to monitor that particular address on behalf of the user. So when it comes to like security, this is being handled like it doesn't have anything to do with the network. It's an off-chain component different from the entire network that is being handled by Axelar itself. So all of the process, in fact, we have some of our relay codes open source. So you can see all of them went to like processes, auditing to make sure that we have everything intact. But as far as the network is concerned, you shouldn't be worried about the security because this is not in any way interfering with what the network is all about or like what the network should do. I just hope that answers your question, Bernstein.
Yeah, I think that was a good explanation. And so basically, just to kind of sum that up a little bit, what you're saying is that the what's been deployed to other networks as well as the Axelar network itself is at all times maintaining the security of the networks it's connected to by ensuring transaction finality before releasing tokens on the destination network, for example.
Yeah, that's a good example. Yes. So moving on, we have the send token that I was talking about, which also allow you to send assets from one protocol to the other. And then this is a function that you can call directly on your contract. So if you are not dealing with any front-end package or SDK, you can just also call this functionality directly on your smart contract. And then finally, we have the interchain token. So this interchain token allow you to send token cross-chain and also build your own assets bridges, build asset transfer into your interchain decentralized application, and even more because it comes with things like no code utilities, Comes with things like fungibility across all of the chains. And you can either choose to use the portal to create an interchain token and then start, transfer, start bridging, add your liquidity and all of that, or you do it programmatically yourself. So this is what the portal looks like. I added this QR code on the right-hand side of my screen. So in case you want to scan, you can scan directly to take you to the portal. And then we have portal for both mainnet and testnet because this is already live. A lot of transaction has been going on, like a lot of application of building, leveraging the interchain token service. So you can test things out on testnet, just get your testnet token and you can create interchain token. You can even register an existing token that you already have somewhere as an interchain token, and you'll be able to bridge the assets from one protocol to the other. So
Very nice solution,
next,
guys, we've seen in
yeah,
practice previously.
yeah. So the next one I want to talk about is this is quite different from asset transfer. This is sending messages from one protocol to the other. So we have two functionality, like two function call available. The first one is called contract, and the second one is called contract with token. Let me talk about. Let me go into detail here. So the first one, which is call contract, right? So if you want to send message from one protocol to the other, we have this function exposed to you. So what you just need to do is to import the Axelar SDK, and then you'll be able to call this particular method on your smart contract. So what you need to specify here is destination chain, the contract address, and then the payload. So the payload here could be an array, it could be a string, it could be, JSON, any type that you want to, format, or like you want to encode to send message from chain A to chain B. And then we have the underscore execute function here. This is a function that automatically runs on the destination chain by itself. So let's say, for example, you send hello world. All right, let me use a two-way call example. So you want to send hello from base to optimism, and then you want optimism to return to send back word, which is a way to acknowledge that, yes, I've received this message on the destination chain. So what you just need to do here is that you can encode that kind of functionality under the underscore execute function. So encoding that means that it's going to listing, because this function gets run automatically whenever the transaction is completed, like end to end. So there's a different stage of transaction, which I'm going to show you within during the demo session on Axelar Scan, where you could track how things move from source chain to the paying gas, and then through the network, confirming, approving, and then execution. Execution stage there means that the system is automatically executing whatsoever we have in this underscore execute function, and then it's triggering this particular function automatically. So, and this function takes in like the source chain, the source address, and then the payload that was sent from the source chain to the destination chain. Right. So let me talk about the second one, which is called contract with token. So the first one, you send message, but this one allows you to send message and even assets alongside the message. So here you need to specify destination chain contract address, and then the payload, and also the symbol, like the symbol of the asset and the assets. So a typical example here is you want to send message, you want to give bounties, right? And then you have like selected projects that have submitted their addresses. And then they also, like, they submitted different addresses, which means they don't care, like they can receive the funds on any chain. So if you want to send like this bounty to all of these addresses at once on any chain, which it can be triggered to, then once you call this method, all you just need to do is to specify the destination chain, specify the contract address, and then you can encode the payload. You can encode all of the receiver's address inside the payload, and then the symbol and the amount. Then under the underscore execute with token, where we have the source chain, source address, the payload, and then the token symbol, you can decode that payload that was sent from the source chain, which includes the user's addresses that wants to receive that particular bounty. And you can now do transfers to all of those accounts on the destination chain. So it means that I can send, like, I have assets on base, and I want to do giveaway on optimism. So all I just need to do is like set up this method, call this method, and then add all of those addresses. Then whenever the underscore executes with token method get executed, automatically it disburses the funds to those address that was encoded on the source chain. So yeah, that's pretty much like the two functionality that you could get as of today with the Axelar general message person. Now the big picture. Let me kind of explain what it looks like to send message and also what the process is all about. So a typical example here, we are using the source chain as Ethereum and then destination chain as base. And we have, let's say for example, a user trigger this particular function on the source chain. What it's going to do is it's going to go through like the gateway deployed for that particular chain, which emits an event through the Axelar network itself. And then after validation and the consensus have been made, like all the validators vote and approve that particular transaction, it goes directly to the gateway of the destination chain where approved core contract call is triggered. So this approved core contract call is ensuring that yes, truly this call was triggered from the source chain, of course, the security I talked about, and then to double check that yeah, everything is good to go and the validation has been completed and everything it has reached consensus and it's good to go. Like voting has been completed by the validators on the network, right? So, and then it goes to the underscore execute method, which I was talking about, that automatically run on the destination chain, and that's like the end-to-end picture. So if I'm sending message, let's say I'm sending hello world from Ethereum, it goes through this process, and then on destination chain on base, you receive that hello world. So you can just call and then receive that message that was sent from chain A to chain B. In this case, Ethereum to base. Yeah, are we good?
Yes, there is one question in the chat I want to pull up here in case you want to elaborate on this at all. The question is regarding the call contract with token function. When I
Yeah,
call it with ETH on Cepelina, so they're talking about testnet here, how
yeah.
do the ETH assets get generated on the destination chain exactly? Like how does that work maybe from like a top-down level?
Yeah, so the cool part is that all of these assets, we have different chains connection, and we have assets that is supported with Axelar on all of these chains. So depending on the type of assets, typically ERC20 token that you want to send from one chain to the other, we already have all of these assets supported on all of these chains. Just think about it. We have 60 plus chain connected. All of these assets has been deployed on all of the chain. So let's say you want to send like the ETH Sepolia, just like you mentioned, you want to send like an ERC20 token, like maybe AUSDC, for example, which is the Axelar ERC20 token that we deploy on the testnet for developers to test. All you just need to do is to specify the assets, the amount, specify the symbol of that particular asset, specify the destination chain, the destination address, and then you can trigger it. So once the transaction has been completed end to end, because the asset is also supported on the destination chain, it just automatically, it will arrive at your wallet because it's both supported on both chains.
Perfect.
Yeah,
I
I
think
hope
that
that
clears
answers your
up.
question, Kazu. I think that's Kazu. Yeah, I hope that answers your question. Yeah. So now back to the presentation so you can see what the big picture looks like, right? And then this is how the flow happens from one chain to the other chain. So now let's take a look at, like, we'll be going through the demo session, but this is like the end result. This is what the end result looks like. And then in this end result, you see where we can send message and can trigger. In this example, I use Binance or Avalanche. So we can send any message quickly, and then we'll be able to receive on the destination chain. So in this example, I sent Moralis from Binance to Avalanche. This is message. So in this case, I'm just sending a string. So it could be an array. Don't forget, you can encode whatsoever in that payload, and then you'll be able to send it from chain A to chain B. So let's go to the demo session where we will be, we'll clone a simple Next.js UI that was already created. And also we'll write the smart contract, we'll deploy the contract to get the contract address, and then we'll connect the smart contract to the front end. And finally, we'll test our application. So let me switch right now to code. Yeah, it's about time.
And if you're
Yeah.
watching this in real time, guys, there will be a recording. So feel free to come back later on, pause, go back in case you want to follow along yourself, because we're going to keep moving pretty quick as we go here. And also feel free to post any other questions in the chat as we go. Thanks for participation, guys.
Yeah, thank you very much for joining. So one thing to note here is that this is a project. Let me zoom in a little bit. This is a project that has already been made. I can share like the link to you that you can just clone directly. The cool part is we have the UI and then we have the contract. So let's go through what the contract looks like real quick. Yeah, we'll be quick here. So what does it look like to send message from chain A to chain B? This is a contract that was created to do that for this demo purpose, right? You can see the first thing I need to do here is to import the Axelar executable from the Axelar GMP SDK Solidity. And then I also import the interface for the gateway so that we could interact directly with the Axelar gateway, and then the Axelar gas service. You might be wondering, why do we have gas service here? The cool part is that for gas service, no, they'll think of it like you want to send message from base and to optimism through Axelar. So now we're talking about 3 chains here, right? We're talking about 3 chains, and then these 3 chains. Sorry, am I still audible?
Yes, we can hear you. Yeah,
Perfect.
so yep, we got the 3 chains involved. We're going from, you said base over to optimism, was
Axelar.
it?
Yeah, to Axelar and then to optimism, right? So think of it like you need to pay like 3 gas. Like you need to pay gas on base, pay gas on Axelar network because it's a network itself, and then pay gas on optimism, right? But then we've
And if you
created the
were to
gas.
do this manually, I mean, even figure out some way, you'd be looking at not only paying gas 3 times, but 2 different assets, because Axelar uses AXL for gas, but then your other 2 networks, they use ETH for gas.
Exactly. So we have all of these, use cases here that you need to like pay this gas. But the cool part is that we've created a gas service contract that you can just use that allow you to pay gas with the native currency on the source chain. So you can just pay gas once, and then that gas will be used for the end-to-end execution of that particular transaction. So you don't have to worry about, changing to like the native currency for AXL and also for optimism, which is the destination chain in this case, right? So another one is, because this is like core contract, so we won't be needing the ERC20 token import here because we are not sending assets. What we were doing in this example is to send message. Then we create a very simple contract that stores like variable. So we have state variables where we store the value, we store the source chain, and then also the destination chain. I'll tell you why we need to store like the source chain and the destination chain in a moment. And then we are creating a variable for this gas service from the interface that we just imported at the top. And then you can see in the constructor, we are specifying the gateway and then the gas receiver. So the cool thing, the thing here is that because we have different gateways, like for EVMs and then for other network, right? So because they are different, you need to specify which one so that the network understand, oh yeah, I'm supposed to interact with base on the destination, on the source chain, or like base on the destination chain. You need to specify which one, and also you need to specify the gas service. So I'll also show you where you could get all of these things. In fact, let me go over to my browser and then show you what it looks like in a second. So if you go to the Axelar documentation here, and then let me start from the beginning. You go to Axelar documentation, this is what you see, which is docs.axelar.dev. You click on developer, and then you scroll down a little bit here. You can see contract addresses. You click on testnet. So we have testnet and mainnet, right? So this is testnet. So this is what I'm talking about. So for every chain, we have like the gateway contract and also the gas service contract. So this is the addresses that I was talking about. So for Avalanche, you can see this. For Binance, you can see like we have a lot of them for different chains, right? And then the same thing for mainnet, right? So let me go back to our code. So in our code here, we'll need to specify these 2, addresses. And then we also extend the Axelar executable here, and we're specifying whatever that's, gas service, we are saving it into this, particular variable here. We're assigning to this variable here. And then that's it for the constructor. We proceed to like the actual function that allow us to send that message. So yeah, the function is going to take in 3 parameters. Where exactly is this message going to? Which address is it also going through? and then what value, like the message you want to send. So the first thing we are doing here is to encode whatever message that was sent here. We encode that particular variable or that particular message, because now it has payload, right? So it could be a string, it could be an array or whatever you want to encode. And then we also want to make sure that gas has been paid. And then after that, we can now proceed to, call the pay native gas for call contract call, that we can now add the gas, which we need to just pay only once. We specify the address where it's coming from. We specify destination chain. We specify the destination address. Then we specify the payload. And then you might be wondering, why are we specifying message or sender here? So there are cases where you could have, like, for your end-to-end transaction call, maybe you send in a particular gas amount that is higher, and then after execution end-to-end, like, we have like leftover gas. That leftover gas will be refunded automatically to this particular account that is specified here. So you can decide not to specify message or sender, which is the person that is calling this particular function. You can just specify a particular address. It could be a multi-sig wallet or anything that you want to use to save refunds, and then you can have it there. Then finally, after everything goes through, like, we are sure that gas is paid, we've paid gas, we call the gas native call contract call. Then we can now call the actual function to send the message. So here we're passing in the destination address, we're passing in the destination chain, the destination address, and the payload. And that's all we need for the send message method to send message from one chain to the other. And then finally, I talk about the underscore execute method that handles that automatically gets run on the destination chain. Here you can see, like, we have the source chain, the source address, which you can also use to prove that this message is actually coming from this chain that you specify, or the chain, the expected chain, right? So here we specify the source chain, we specify the source address and the payload. And then what we are basically doing here, since this would get run automatically, we are decoding that particular payload and then saving it, saving it to this value here. You can see the payload that was received here. We are saving it as a string, because it's a string, of course, because that was what we plan to send from the destination, the source chain to the destination chain. And then we are setting the source chain and the source address, which is another way for you to verify where the call is coming from and then which address the call is coming from, right? So, and we are also using this to, like, showcase it on the front end, that you can just read the state variable on chain to see what was stored there, and then to verify that it's actually coming from the chain that you intended, right? So now that's all you need for the contract. Because of time, I've already deployed this particular contract. But then to deploy the contract, I can just show you real quick what you need to do. So this is a very simple script to deploy the contract, and you can see what I'm doing here. I'm calling the contract, and then I'm specifying the gateway and then the gas service. So depending on the chain that you want to deploy to, and then I'm deploying it. That's all you need to just deploy. You just need to specify the gateway address and then the gas service address that we looked up on our documentation earlier on. And then after that, you deploy this particular um, contract, and then you are good to go. So every other interaction left is, now you need to save that particular contract address, of course, because that's the contract address we'll be interacting with. And then we have this very simple and complicated Next.js, JavaScript code on the front end, which is like the React code. You can see we are importing all of this contract address. So in this case, it's Binance to Avalanche, right? And then I'm just importing all of these things. I'm setting a few variables. But the most important part here is where I'm actually doing the call, which is on line 28 here. I'm using these hooks from WAGMI, right, that allow me to specify, like, the contract I want to interact with, the chain, the ABI, specifying the method I want to call, the chain I'm interacting with, and also being able to pass all of these variables directly, which this send message function is expecting. And then I'm able to do that. I'm also able to specify the gas. And then moving on, I have, these are all functionality for the hooks. If you choose to use the WAGMI hook, which I feel it's very cool stuff that you can play around with. And then after that, after the transaction is sent, I call the write function here. After the transaction is set, I wait for it, and then I do a toast notification, and that's it for sending. But for reading, now that I've sent the transaction has been completed successfully. I want to read the variable to be sure that yes, I now have the value that was sent from the source chain to the destination chain. Then I created this very simple method that I just basically read the value from the contract and also the source chain from the contract. So I'm setting both in the state variable, in the variable that we declare here. So now that's it for read. And I'm calling all of this. These are just like UI modification. It doesn't have anything to do with interaction. So once the transaction is successful, it sends a message, a toast notification saying, hey, message sent successfully. And then if there's an error, it errors out so that we can know what the problem is. And yeah, so every other thing here, you can see there are a lot of styles, like a lot of stuff that you can play around with on your own. This is just to showcase what the front end is going to look like. And then we are setting a few variables here that we're reading on chain into this particular data block that we have from, to, and also the particular message. So I have this started already. Let me go back to my browser here, and then I should see it in my localhost. Okay, looks like I need to start this server again. 1 second. So it's npm run dev. Yeah, so now I want to start this off. This should start in port 3000, and then we should be good to go. Let me change this to port 3000. Oh no. Okay. Yeah. So this is what the application looks like, right? So we have this. So the reason why you are seeing this response here is because I already have like a sample contract that I've deployed, and then I've deployed on Binance and Avalanche, and then the system is reading the data on chain. So let me try to connect my wallet so you can do all of this. The cool part is that Wagmi just exposes like all of these things to you, and you can just leverage it automatically. And then I can just connect, and it's going to ask me to switch to Avalanche, which is the destination chain here, where this data is being read from. So now let me show you something. So if I go back to my .env variable on the front end, right? We have, you can see the contract address here. So let me try to change one thing on the contract here. I want you to see what the UI looks like. So this is what the UI is going. Okay, sorry, that's not complete. Let me just be sure. Yeah, and let me just put B, and then this is intentional, right? So let me try to refresh. Yeah, it's showing error because, of course, it's incorrect. So, but then you can see what the UI looks like. It says waiting for response. So this is what it will look like when you clone the project and you are trying it for the first time without, maybe you've deployed your contract, but you have not interacted with the contract yet. So let me just go back and then return the settings so that we have this contract. And then one thing we can do here is to switch, since I'll be testing from Binance to Avalanche, I can just switch my network. Let me switch my account back to an account that has faucet, and then I can switch my network to Binance. So this is, I'm just using this as an example. Feel free to use, any supported chain. Right. Just take a closer look at this. This is showing from Binance to Avalanche, and then we have this message. So now let me send in a new message. Which message? Phil, which message do you want me to say?
Oh, how
What do you
about
want me to say?
congratulations, Axelar from Moralis. And the reason we're saying congratulations, guys, is I forgot to mention this at the beginning. New partnership between Axelar and Deutsche Bank recently announced. So congratulations to you guys on that. And we'll send a message commemorating it.
Yes. Yeah. So since I'm connected now, I can just proceed to click this, and then you see this toast notification. These are all of the codes that you were seeing the other time. So many front end stuff. Yeah. So then I click confirm. We have these, and saying sending message, and now says message sent. So we can just look at this on our MetaMask so that we can copy the transaction hash here. So yeah, this is updated already. So now I can just copy the hash. So one cool part is that message sent successfully, which is from Binance to Avalanche. Let's take a look at how this message moves from chain A to chain B. So you can navigate to like testnet.axelar.scan.io, right? Which is an explorer that you can use to track your transactions or like the activity on chain. So we have for both mainnet and also testnet, right? So I'm going to like paste in the address here and then click on search. So searching through this address right now, and then we should be able to see transaction status, right? So you can see it shows sent here, gas has been paid successfully, transaction confirmed on chain is currently approving. And you can see other details like the source chain, the destination chain, the sender, which is my address, and also the contract, when it was created, and then like the estimated time spent, like the time spent general, and then the estimated time spent, like depending on what happened on chain at the point, and then the base fee and gas paid. So if you want to see more, you can just click this to see like other information. But then I don't think we need that. So you can also track like all of these things happening on chain. So we have like this from where it was sent. I can click to verify that yes, truly it was sent from Binance. And then we have it has been approved. Let me scroll up. Yeah, you can see it has been approved. You can also track that here. So let's wait for the execution on this destination chain to complete. Yes, so you can see it changes to like executed, completed. So now we have all of the stage complete end to end. So we can just go back real quick to our transaction, to our decentralized application, to our dApp, right? And then I'm going to switch this to Avalanche, because Avalanche is the destination chain in this case, and that's where we want to read our data from. And then once I switch to Avalanche, and then you see the message gets updated automatically, because now we can read this particular message that was sent from Binance in this example, which is the source chain, to the Avalanche network, which is the destination chain. How cool is that? You can see like we have message sent from chain A to chain B. Very easy. All we just need to do is to interact with the Axelar SDK, deploy this contract for both chains, and then we can send messages across these two chains. Right. So this is not limited to like Binance and
Really good
Avalanche.
stuff. And the experience we're having here, and then looking at the Block Explorer as well. And if you've spent any
Yeah.
time with block explorers like I do every single day, you know that what Axelar is bringing to the table here with easily interpretable data and information, and then links to the other explorers for the other chains, is as good as it gets right now, guys. And also kudos to you guys for a great visual enhancements recently that you can see on that main Axelar page. So definitely check that out, axelarscan.io,
Yeah.
I believe it is.
IO. Yes,
Yes,
correct.
perfect.
Yeah, so I love dark mode. So I was just switching in case you guys you guys love light mode. And then one cool thing I also want to talk about, which hasn't happened yet, is that whenever you say, for example, you pay like SS gas, I think I mentioned that during the presentation, and then after the transaction gets executed end to end, there are leftovers, right? You get refunded automatically to the address that was specified. So one thing that you can also use to track that is that if there's like excess funding, or maybe you pay like excess gas, maybe you just had coded like a random number, you can come back to the transaction, can always come back to the transaction here. You see additional status showing here when the gas refund is completed. So you can also see that, yes, truly I've overpaid. But then we also have something I want to quickly talk about here before I go back to the presentation. So we go to the Axelar docs, and then you click on developer. You go to the Axelar GS SDK here. We have the Axelar query API that you can use to estimate gas fee. So we also noticed that, right, why do you want to even pay more in the first place? Why not get something that could estimate what the total amount should be, or like for the end-to-end call? So we created another SDK that you can use on the JS side when you're triggering that particular transaction, that could estimate the actual amount that will be required for your transaction to go cross chain and then to be executed successfully end to end without having to wait for like refunds, without having to wait like to overpay and then wait for refunds. So, but if you use this SDK, it makes life easy. And then you're also sure you can also see the breakdown of like how fees are being paid. And you can just make this function call and then to return the exact amount that is required for that particular question call, depending on the network. So depending on the specified network, you can see like the interface here. You can see a few things. Yeah, let me see. So you can see we have like the source chain, we have the destination chain, we have the gas limit. You can specify the limit, you can specify the multiplier and all other information, right? So the most important thing here is specifying the source chain and destination chain so that the system can understand, hey, this is going from base to Avalanche or base to Binance or base to any other network. And then it could return an estimated value based on the exact amount that will be required for that cross-chain end-to-end execution, right? So that's one thing I want to call out that is already available. The developers can try it on their own. So now back to presentation. So that's it, guys. Like that's how cool and easy it is for you to try things out on your own and also send messages from one protocol to the other. So moving on, we have the Axelar example. So we understand like how important it is for developers to quickly get onboarded. But apart from showing you, oh, this is what you need to do, this is what you need to do. We've also created Axelar example repository where you could check out, just Google Axelar example, or you go to github.com/Axelar network/Axelar example dash example. So this is a repository that contains like a lot of code snippets and examples that you can try out. And the cool part is that it's also integrated with the Axelar local dev, which means that even though you don't have faucets, like you don't have testless faucets, faucets are hard to get these days, depending on the network. You can just spin up the local environment and then test this end-to-end interaction locally on your machine, right? You don't need any faucets. Everything is already set up for you. You can just test things out on your own. So I would encourage you guys to check it out. And additionally, we have for Axelar Foundry example. So in case the first one is hard hat, right? And then in case you are, a Foundry developer, you love Foundry, we've also prepared another repository that you could check out yourself. And then you find like examples there. We are actively working on all of these, example repo to add more example to improve on what we currently have and then keep making things better, right? So check it out and then let us know if you have any feedback. So aside that, what next? We also provide support for our developer ecosystem. We know beyond just giving you what to do or like telling you what to do or like giving you some of these examples, giving you code snippets. We also know that you might have like questions, you might run into bugs and all of these things. We have created a repository which is called the support repo, and it's under the github.com/Axelar network/support. You can open a new issue if it hasn't been created before, and then we'll get a notification and we'll be happy to help you. You can also join our Discord server, to learn from other people and see what other guys are building. Right. So yeah, finally, I have this very small QR code for survey, like a feedback that I would encourage everyone watching right now to, snap and then tell me what you think about this session, how this session has been able to help you one way or the other. It literally takes less than 1 minute, right, to fill in this survey. It's just like checking things out, like checkbox, and also learning from you if you find this presentation helpful so that we can double down on this type of, presentation and workshop to help you guys understand how to build leveraging Axelar, how to build an interoperable ecosystem to interact with any chain anywhere. And of course, you can reach out to me. I'll be happy to help you. Thank you so much for joining.
Well, thank you for joining us, Idris. And I also wanted to mention, if you're developing with Moralis, we're also here to help you. Check out the link for the Moralis Discord below, and you'll find lots of resources there. And of course, we encourage you cross-chain and interoperability developers to leverage both of our solutions, because that's really the key moving forward, working with the best tools and the best teams to support you in what you want to bring to the table. And that's exactly what we have for you here today. Thank you so much to all of our viewers for joining us today. Another thanks to Idris and Axelar for joining us with another great presentation. I encourage you guys to check out some of our other videos if this interests you, and we'll see all of you in the next Moralis Presents presentation. Have a great day.
Yes, guys. Bye.